Now we are starting again. Welcome everyone. What a hiccup with this YouTube live streaming here. Not the smoothest web experience. So, welcome to more regular programming. After our short service announcement, of course, not regular topics here. Back to more IT talk. We took a look on Clang recently because we wanted to build a full Clang, Clang, or whatever you want to call it, system. Welcome back, Danny. And obviously I was curious what results do we really get there, because the initial results did not look so amazing. But of course we spent here all efforts possible to compile more data, and do more testing and such, and more data is in. And to take a look here, because initial results were not the most amazing, as I said, I built here the whole set of benchmarks on the system, GCC8 and latest Clang here on the same AMD Ryzen, and this open bench from a decade ago, and this is the way it was actually initially intended to be used, or I wrote it initially for 2005 or 6 or something. Of course, in the meantime, these benchmarks are rather short. Back in the day, whatever that was, 2 GHz core to do or something, they run longer, but they still run forever if you run this on a Sun UltraSpark MIPS, SGI MIPS and Hewlett-Packard HP PA RISC, then this runs here easily for an hour or maybe a whole day or afternoon. So still a point if you want to compare this with other vintage machines. The longest running benchmark here obviously set standard, which I only added recently, and otherwise I think this is still, you see, even when it runs so short, it's still comparable, and in my opinion not a bad thing to have short running benchmarks that you can compare with vintage machines. So if you take a look here, first of all, this is build time, which I was wondering. So of course this is here sorted by GCC levels. At the front we could also sort it better, but this is here automatically with pipe through sorts, so that's what we get, not manually handpicked here, otherwise I would have moved S here in between somewhere, but whatever. So build time obviously with 0, certainly the shortest. And then the more optimizations you switch on 01, 2, 3 or S for size optimized, the longer it takes. Of course, size optimized is usually somewhere around 02, 01, something like this. But another thing, we see that Clang is not really faster. If you take here a look for one benchmark, BZIP2, 0.4 seconds, of course parallel 16 times 16 threads. So 04, 04, 06, 067, so yeah, and then okay, maybe here it's slightly faster in the area of 02, but yeah, whatever. Also OS here is significantly slower. The picture is similar for all the benchmarks without optimizations, usually quite fast here. As soon as you turn on more optimizations, stuff starts to slow down, obviously, at least here build time wise. Just to give you a broader picture, because initially we only had here run here one Clang, I don't know, libmet or lame or what it was, but the picture is here similar, and the times in my opinion here, well, here maybe a little bit faster, 2 seconds, but in general I also see when I compile the whole system it's not that amazingly faster or something. So maybe it was, Clang was faster a decade ago, but in the meantime the more code they added, the slower it certainly become. If we take a look on the maybe more interesting for you and most other people is runtime. This is of course what most people are interested. By the way, why does this not run longer? Okay, maybe there's some bug or issue, whatever. First time because I just came back and have here new results. And but anyway, let's ignore the 0 thing here. Maybe something. I usually have run my code with OS, optimized for size, because this was also with smaller, or not smaller, but yeah, well, smaller CPUs from back in the day, slower CPUs, smaller caches, because back in the day, 10 years, OS size optimized was often faster because the code, the compiled machine code, fitted more into the CPU caches, and thus often run faster, not always, but often. Of course, if you had some hot loops, then 03 could speed things up. But general, for larger programs, general system stuff, we often found OS to be preferable. And here you see also why. Runtime, of course, is here quite similar. You see OS here somewhere, yeah, around, strangely enough here, anyway, slower than 01, but whatever. Usually you see here OS even is the second fastest tier, is even faster than 02, and otherwise stuff is pretty similar. Surprisingly here it's slower than 01, but whatever. And here also, But anyway, you get the idea. This optimization levels only in very special cases make such a huge difference. Of course, right up you see 03, this takes so much longer than to compile, and this for me is usually simply not worth it, especially when I wait here a whole day or afternoon or night for some T2 builds to finish. Makes no sense if I wait here twice as long for something often not even running faster. But of course, again, if you have some multimedia loop, and by the way, this is with native instruction set, so without vectorization. Of course, the picture can change dramatically if you turn vectorization on, but this is not something I wanted to compare here, especially as if you compile for plenty of people, then often you don't want to use the assistant. But otherwise, this is also what I used a decade ago in the Linux Magazine article to take a look on the binary size. And then I looked over this, is that sometimes, actually now that I look on this again, not often, so Clang OS does not even consistently, no, here it's often faster. Here it's bigger, I mean, here it is slightly smaller, but OS with Clang is not even smaller. So yeah, but again, it is interesting. I will take a look in more depth here, what I can find. Can we make this faster? Can we use it? Of course, if we make a system like this, we save having two compilers in there. And if the compile time, it is not as bad as I initially thought it would be. If you take a look here, 02, here it is just a second small faster, but okay, a second is already some 20%, right? And here it is with 02 at least, it is sometimes quite a bit slower, but I mean, yeah, quite a bit, 20%. Anyway, you get the idea. Just I wanted to share some more data that you have a more, can form your opinion here based on more than just one lame benchmark here. But in general, yeah, slightly disappointed that it's neither faster to compile nor that much faster code execution. But anyway, this is a big, the more summary here I wanted to share. Not that people tell me I only look on one result. I can't make here some big claims based on one result, but whatever. I have one more thing to share. So we end this live stream now to have here some small live streams for small subjects. I hope you learned something from this interesting, and I will go live in 5 minutes to share another detail. So don't forget to share, like and subscribe, and I hope to see you soon for the next videos to come.